Hey everyone, today I'll be going over Leetcode 167 2sum 2 input array is sorted. So they have all this junk here, but I'll just make it easy for you. It's the same as 2sum. You're given a list of numbers, you're given a target, you have to return the two indices in this array that add up to the target. Same exact as the traditional 2sum. I'm not even sure why it's medium. It's because the input array is sorted, so they're giving you a big hint here. So 2sum 1, the trick to achieve O of n time complexity is to use a hash map. The hash map takes O of n space, worst case, so O of n, O of n. This one can actually be solved in constant space, and maybe that is why they marked it as medium, is because you have to realize. So when they're telling you it's sorted, the hint is in the title itself. So you have all of this junk here. The only caveat is when we return the indices at the end, we have to add 1 to them. Not even sure why. 1 indexed, I guess. They are guaranteed to have a solution, so we could just return some dummy array at the end. Okay, and that's pretty much it. So like I said, the hint is in the title itself, so that'll make it super quick after you'll see it. If you don't see it, so we're given a list of numbers, we have to find the 2 that add up to 9. Obviously we see the 2 and 7 here, which is the answer, which will be index 0 and 1, add 1 to both of them, and it's 1, 2. But to actually do this algorithmically, you can do original 2sum, keep a hash map loop through it, you can do that. But because it's sorted, they're urging you to take advantage of that sortability. And you can also use binary search here, but I'm going to do the 2-pointer method. So if you have 2 pointers, left and right, you know that increasing the left one will always increase the sum. The proof of that is that it's sorted. So the one to the right will only be bigger than the one to the left. So if we increase left pointer to 7, we know the sum will increase. So if the sum is ever lower than target, will increase. If it's ever higher than target, will decrease, and we do that by decrementing the left pointer, or the right pointer, because same logic, it's guaranteed to be smaller. So let's declare those here. So we'll go int left equals 0, right equals numbers dot length. Okay, so we have our pointers, and then we'll go until they meet. And because we don't want them to be equal to each other, because that would be the same number. If we ever get here, we can just return an empty array just to silence the Java error that we didn't return anything. Although because we're guaranteed to have a solution, we'll never get there. So what do we do here? First, we get the current sum, which is just simply numbers.left plus numbers.right. And then what we do is the very easy case. We check if sum is equal to target, because if it is equal to target, we just return the 2 indices, 1 indexed, right? So for this, we'll go left plus 1, right plus 1, like such. Okay, so this is the easy case. If we get here, we get lucky. The first one, it's like this. Else, if sum is less than target, so this is that case, it is less than target, we need to pinch these together. We need to increase the sum because we need to get closer to target. So to increase the sum, we should go left plus plus, because this is guaranteed to make the sum bigger. Else, the only other case is that sum is now greater than target, which means we have to do the same. We have to decrease the sum. And let's run this. And like I said, this is a really easy one. It's an easy one if I'm smart. And we have to go -1 up here because we'll be out of bounds right away. And we have this here. So let's submit it, and then we can look at the submission and talk about time complexity. Looks like it's pretty good. It beats about 100. So let's talk about time complexity. The time complexity is O of 1, same like 2sum 1. And then you're probably thinking, what is the advantage of this over the first solution? Why can't I just do my normal hash map thing? That is because the space here is constant space, because we're not using a hash map to store, to cache numbers. We're just using 2 pointers and pinching them together. And then also the proof for why it's O of n is we're going until left meets right. So worst case, we will just step through every number. The absolute worst case is that left and right meet exactly in the middle. And in that case, we've just counted every number, so it's O of n. So yeah, short video, but hope this made it a little bit more clear. Thank you for watching.